I'd like to introduce our speaker, Tariq King. Tariq has more than 15 years of experience in software engineering and testing. His expertise lies at the intersection of software products, services, and technology consulting. He's published over 40 research articles, and his PhD research spans artificial intelligence, autonomic and cloud computing, and model-driven engineering, among other topics. Over the years, Tariq has applied this experience to some of the most difficult real-world engineering challenges, and has been a keynote speaker at software conferences all over the world. Today, Tariq is going to dive into the idea of force multipliers and show us how combining a variety of these approaches can lead to exponential benefits. Please feel free to drop questions in chat or share your experiences. We'll answer questions at the end of the presentation. Let's go ahead and get started. Over to you, Tariq.
Thanks a lot, Zach. Let me just share my screen. I don't know if you guys can see the screen.
Looks good.
All right, cool. All right, yeah, like Zach said, force multipliers, right? So I'm pretty excited. This is our first webinar with Test.io. I'm recently a new member of the EPAM family, been here about 3 months. And just kind of excited to see like all of the different things going on throughout the company. So really appreciate the invitation. All right, so we're going to cover a number of things, but first just kind of an introduction to force multiplication. We're going to talk specifically about force multipliers in software engineering. Again, the most common thing that comes to mind is tooling, but there's a lot more to that. And then dive into how do we combine force multipliers and the impacts on quality and testing, and then wrap up and have Q&A. So anyone that knows me knows that I love my family. So these are my 2 royal princesses, Soraya and Mackenzie. And I always try to integrate some aspect of real life into the concepts that we dive into from an engineering perspective, because at the end of the day, we live in a world that is full of science and technology in itself. So when I thought of this topic, I thought, oh, well, you know, my girls like seriously feel that they're superheroes. Like they always think that they can do just about anything. And so, you know, what if Soraya had the task in front of her to move this boulder? Like, could she actually move this boulder on her own? Probably not. She's 9 years old, but this looks pretty sizable for a 9-year-old. But what if she had this, right? What if she had some sort of a lever where she could exert some force around the pivot and then, you know, have that force be applied to the load, right? So in this case, this lever actually acts as a force multiplier, right? Reducing the effort needed to move the load by increasing the distance over which it's acting away from that pivot. So as a result, like we have like these very small forces that can have much greater effects or impacts. But that seems pretty straightforward, right? That's Soraya, but Mackenzie's smaller, and apparently like the smaller that they come, the more they think that they can do. So what if I asked Mackenzie to lift our Tesla? Could she actually lift the Tesla? Well, the answer is obviously no. But if she had a hydraulic jack, there's a different story to be told, right? She could exert pressure on the fluid inside that cylinder and compress it, and the force would be exerted over that large distance. And like using Pascal's law, the force would be equally exerted in all parts. And now we have a broader area giving a multiplication force that could actually lift the car, right? So the idea here is that you want to be able to work smarter and not necessarily harder, and that the tools that we have actually allow us to do that and allow us to have this multiplier effect across the efforts that we put into whatever we do. All right. So with that, it's time to actually step into battle, but we have to arm ourselves with knowledge around force multiplication and just look at some more examples. So tools are obviously very good examples. And like I said, these are the first things that come to mind, whether it be a screwdriver, a hammer, a saw. But one thing to note even on tools is to remember that not all tools are necessarily created equally, right? There's tools and then there's power tools. So we can actually leverage additional technology on top of tools to help make them even more effective or have an even greater force multiplication factor. But it's not all about tools, right? There's technology as a broader span than tools, but people can also act as force multipliers as well as processes or methods, right? So let's start with technology as a force multiplier. When I talk about technology, I'm really talking about the process of transferring scientific knowledge into some practical use. And so if we go back as far as 1712, what really led to the transformation and the powering of the Industrial Revolution? It was the creation of these steam engines, right? So by the 19th century, we had stationary steam engines powering factories, and it was all the result of this one kind of invention on this tool or this particular piece of technology once it came together. So we're talking about replacing sail ships, paddle steamers, steam locomotives, everything to do with railways. It just transformed quite a bit around us. In terms of people as force multipliers, there's two things that normally come to mind. First, there's like your individual contributor. If you start to think about Tom Brady, he holds nearly every major quarterback record that you could possibly hold: passing yards, completions, touchdown passes, everything, right? And when Brady is embedded, he's not just acting as a player on the team, he's also acting as a coach, as a motivator. He's doing a lot more, and the teammates around him actually feed off of that skill that he has and that he brings to the table, and it has this multiplier effect on the team. Of course, the team itself, this is my version of the big three until the other big three came to Miami. But when you start thinking about the team itself and you have these highly skilled players that are not only in themselves, obviously, force multipliers, but when they come together as a team, there's an additional multiplication factor, right? So Jordan and the Bulls, Rodman with his rebounds and Scottie Pippen. So we start to think about, the scaling factor of these multipliers, and it kind of creeps into combining them, right? Because when you start to combine them, you get an even greater or even exponential growth. All right, so process, again, this is more thinking about, the way that we do things, and that comes into the assembly line production as a good reminder. Thinking about how to break down manufacturing in a way that the steps are completed in this predefined sequence. So the assembly of a car, typically maybe one car might take about 35 minutes to assemble. But on the assembly line, if your engine installation takes 20 minutes and the hood installation takes, 5 minutes, and you keep on going up and installing the wheels takes 10 minutes, that 35 minutes per car now gets drastically reduced because assuming that there's no loss when you move the car from one station to another, now the throughput on the assembly line, which is based on first, of course, assembling those first few parts, but then, every 20 minutes from there on, you can get another car, right? So 35 minutes to produce the first car, but 20 minutes thereafter to continue the assembly line pushing through. So again, we kind of see this multiplication factor. And again, these things revolutionize a lot about what we do. And process kind of brings together a few things, but it can be more isolated, like a method or a technique, right? So this is kind of another form. But when you think of the Spartans and their what is called the phalanx method, they basically would lock their shields together and have the few first-ranking shoulders project out their spears. And now they had like this wall, right? So even when there was less of them against bigger armies, now they were more impactful because they had this method that allowed them to kind of stay very defensive and slowly but surely eat away at the enemy, right? All right, so software engineering and engineering as a whole, right? And kind of put together this graphic to remind us that like force multipliers may come in the form of people, like the person actually sitting at the machine, but also maybe some of the tools that may be in front of him, or maybe an interaction with a colleague in the upper right, or it could be as simple as that coffee mug on the table, and we'll get to what exactly I mean by that as a force multiplier. Not that you should all start drinking more coffee. But when it comes to engineering tools, we call everything a tool, which is sometimes a problem, right? There's libraries, there's frameworks, and there's platforms. But these things all help to accelerate development, right? On one side, a reusable library solves a given problem. It can be trusted. You can just plug it in and go from there. Or if you're building something larger, you have a whole framework by which different things can be plugged in until you get your domain-specific solution after plugging in that framework and all the different components. Then that's great. Or a platform which is actually designed not just for development, but for operation of a particular set of solutions for a problem. So these are all tools by their own right, but it's not just about tools. Like when you step into the world of DevOps, you see that there's tool chains, right? And so you see on the bottom half of this that there's several different tool sets around building, around testing, around monitoring, around operating and deployment, and so on and so forth. We could go on for the entire cycle. But that whole tool chain enables development and collaboration across the life cycle. It's not just isolated to a particular point of development. So again, you can now start to think about individual tools giving force multiplication, but now some cohesion across the cycle could actually add a multiplication impact. And again, tools are one thing, but now we start to think about automation, which is a little bit more than just tools, right? You're talking about reducing manual labor. And when I think of something that's automated, and here I'm not just referring to test automation, but the process of just having something that was manual be capable now of starting, operating, and completing actually independently. This whole process really helps to and should be aimed at reducing the manual effort that's involved. But it goes beyond the tool implementation and the tool usage, right? You start thinking about guiding principles that get manifested in practices. This helps to reduce manual effort. Patterns, which are solutions to recurring problems in software engineering. And so you can leverage those, or playbooks if you're looking for a larger guide that actually gives developers and gives testers concrete ways to solve given problems, and even comes along with some code or something that can just be plugged in to solve your problem. And so automation is key there. And of course, specifically thinking about testing, there was the World Quality Report back in 2018, 2019 that actually called out test automation specifically as the single biggest enabler of maturity in QA and testing. Which is interesting, right? When you start to think about where things have been going and, DevOps, et cetera, not surprising. But in that same article, it actually called out artificial intelligence as a force multiplier for testing. And so, again, going from tools and tool chains and even automation now to the larger scope of technology, like AI actually represents a really good example of a force multiplier, not just in everyday software, right? Because we see AI being applied to recognizing cats in a video and facial recognition and almost every aspect, medical diagnosis, in law, everything, right? So we can clearly kind of see those patterns. But it's also a similar thing that we're seeing when it comes to AI in engineering itself. And so we're seeing AI being incorporated into tools that are doing requirements validation. Can I actually tell if my requirements are correct, complete, consistent, using NLP to kind of get an understanding of what is going on and start to look for these inconsistencies, right? So IBM has a tool, ScopeMaster is a startup that is built around this stuff. And so we're seeing AI for requirements engineering and validation. We're also seeing AI being applied to different types of code generation during development, right? You've probably all heard of GitHub's Copilot. You may not be as familiar with DiffBlue, which is a commercial tool for automatically generating unit test code, right? So using similar technologies, like the GitHub Copilot is based on GPT-3 model. So leveraging machine learning and these generative machine learning models to actually generate complete blocks of code, not just give suggestions. Now, suggestions that were, just high level based on signatures. It's actually the full method, right? All right. Oops. And when it comes to testing, also something that's very close to me in terms of leveraging AI and machine learning for testing. There's a lot of tools out there. I just stepped into a bunch here at EPAM in my portfolio. Helenium, which is a self-healing test automation framework for helping automatically recover selectors that are defined in Selenium and automatically updating them. And then DevTools AI, which is kind of more of a vision-based framework for finding elements by using computer vision and AI models, right, as opposed to looking at the DOM. So we're seeing this happening throughout where engineering has all of these different pockets. Testing in particular is very booming right now with the use of AI and machine learning. And of course, one other tool in the portfolio here is Report Portal, which is looking at reporting and analytics and failure analysis and leveraging machine learning to automatically categorize failures and also start to look at how we can define quality gates around that kind of criteria for those automatic classifications. So no shortage of action in the realm of AI and machine learning technologies in engineering. I probably could have spent like the whole time talking about different projects. All right, so moving on to people as force multipliers and in particular engineers. And this is something that I think sometimes it's obvious to people, but some people have difficulty like actually admitting it, right? And so there's the concept of the 10x engineer, which says that the most productive engineers can be 10 times more productive than their average counterparts. And a lot of people have mixed feelings about this, like, oh, it's not really true. But to me, like thinking that that doesn't exist is almost like saying that there's no star basketball players or football players or no rock stars or superstars, right? And, you know, I've worked with people that are very good at formulating problems, you know, doing the right things versus the wrong things, or maybe formulating the problem in a way that the work that they have to do is almost like a order of magnitude less than someone else would have if they did it. And similarly, finding insights and solutions that would not occur to the average person so that they could avoid certain classes of problems. So that's the concept of the 10x engineer. And the idea is that you're really making your engineering and tech skills go a lot further. And so when you think about these people in an organization, they're not just individual contributors that are just doing their job or building code or writing tests. They're actually mentoring junior engineers. They're training others. They're presenting and sharing their knowledge at lunch and learns internally or at conferences externally. They're publishing or writing blogs or publishing scientific articles or white papers. They're acting as networkers, not just meeting people in that sense, but actually connecting parts of the business together, connecting problems with solutions, and in that way, really helping to multiply like the or accelerate the business. And then obviously like innovating and coming up with new tools and so on and so forth, which also themselves will act as force multipliers. All right, so one thing is the individual and the next thing is the team, right? And you know, once you start thinking about teams, you start to realize that yes, just having 10 very smart people in the same room does not necessarily constitute a team. Like a team needs to go through certain phases of development, from forming to storming to norming to then performing. And there's a lot of key aspects of this which deal with alignment with trust, collaboration, the mission, values, etc. And so the good thing here is that once you've actually built a high-performing team, it can start to act as a model for other teams to follow, or even a playground where you want to create more engineers that are, you know, highly skilled or 10x, right? And you have this environment that you can rotate engineers into this team, or even leverage that team as a shared service to serve many more. But the idea is that you want to use those folks and use those types of high-performing teams to actually act as enablers for the organization, right? So these centers of excellence versus a center of enablement, where you're now saying that the impact of this team is going to be multiplied because they're going out and helping other individuals and other teams and creating this multiplication effect as they go through the organization and do that. All right, now back to our coffee situation, right? So I mentioned the coffee cup on the table, and this is really a reminder for me not to drink more coffee, but that the culture that you establish in an organization, so outside of individual, team, and now the entire organization, that culture really makes a difference as a force multiplier, like making sure that people feel valued, that they are appreciated, that they feel comfortable, that they're relaxed. And there's a lot that we could talk about culture. But that itself can act as a force multiplier where you see each employee is highly motivated and driven and moving towards the business. And so when you think about force multiplication as relates to culture, you want to think about things like building trust within the teams and within the organization, diversity, equity, all these things contribute to that aspect of force multiplication. All right, as we mentioned, the crowd. And so I couldn't have like a Test.io webinar and not talk about crowd testing and not talk about the crowd as a force multiplier, as Zach mentioned, right? And so this comes into the power of the real world, right? Having real people at your disposal and lots of them, and that can represent a diverse set of users for your applications, whether it be trying to get an idea of your user experience or your product experience, or trying to do some high volume testing with those people to look at performance. Or the fact that all those people have a plethora of devices all throughout their homes and in their possession that you will not have access to in any lab while you're doing software development or testing. And so the crowd becomes this place where, as software engineers who are not necessarily connected to the real world of users that will use their software in the end, you have this opportunity to go ahead of that by leveraging the crowd for different aspects of validation and verification. Not to mention the conditions that are out there, especially global locations, having people all over the world, being able to tap into that is something that is not easy to emulate or simulate. And even if you do emulate or simulate devices and conditions, it never seems to have the same impact or feedback as doing the real thing with the crowd. So Test.io, this is my kind of like only salesy slide, which is not really salesy because it ties into what I'm going to talk about later. But thinking about having a platform for enabling crowd testing and doing other things that we'll talk about so that you can have real world verification, fast feedback and workflow integration with the power of the crowd testing behind it for regression, functional product experience, user story testing, beta testing, any kind of testing that you can think about. Generally, like the user drives a lot of the realistic feedback, and the crowd is a good place for that. All right, so now process, moving off of people. And, one of the things that is commonly said about software engineering and software design is that it's a wicked problem. And the characteristics of a wicked problem are one in which that you actually don't know how to formulate the problem until you actually start driving a solution. And so it's a non-trivial thing to actually do life cycle management. And, process as a force multiplier is really about putting a lot of principles into practice and getting good at it, whether it be agile or lean or systems thinking and putting those together. And getting the experience and exposure of what it means to truly do this. A lot of the times you see organizations saying that they're doing agile and not everything is really agile. Only parts of development are really operating in an agile manner, but testing is all waterfall, right? And so you have to really not just understand the principles behind these things, but what it means to actually realize them from a practitioner standpoint. And at the end of the day, process is all about flow, right? It's about visualizing work, limiting work in progress, and managing that flow. Think back about the assembly line. If any part of the assembly line gets choked, that really impacts the output, right, and the productivity. And then other aspects of this deal with just having the feedback loops there and being collaborative and so on and so forth, and just making certain things explicit, especially process becomes very important when you have regulatory compliance and other things. But we need to recognize that even outside of those domains and those areas, that process is a key factor in how productive the organization will be from an engineering standpoint. All right, and the last point on the process models is that we have to be able to scale. And as organizations get bigger and bigger, it becomes harder and harder to do these things, right? And so there's a lot of different ways to kind of deal with this. There's scaled agile, there's, the large scale Scrum, there's disciplined agile delivery. There's a lot of different process models out there. And this is not advocating for any particular one. But at the end of the day, like, we have to make sure that you are working through your organization, looking at the nuances of it, and having the right processes in place, or maybe blending or mixing and matching processes so that it fits your delivery model and your culture and so on. All right, so combining force multipliers, right? So we've actually talked about a couple of these already, right? We've covered the idea of combining AI and machine learning with tools and automation, right? These AI-powered engineering tools that we looked at. And again, this is something that we expect to continue, but there's just no shortage of these tools popping up from here or there. And to go back to the analogy of your regular tools versus your power tools, that's what the AI technology and this combination is really doing. Like, AI is actually powering these tools and enhancing them and making them even more powerful than they were before. Another one that we covered was DevOps, which when you look at tool chains plus automation plus process, and culture, like DevOps is really about getting to a place where we get continuous integration, continuous delivery, where you break down silos and the teams are really operating and having group ownership of the entire life cycle, right? And so all of these things come together when we think of this particular combination. And then Test.io, one thing that we didn't mention was, like, you have the crowd on one side, which is very powerful. But one of the cool things that I noticed as soon as I joined and I saw the strategic direction behind it was that, like, oh, we combine like the crowd with professional testers at EPAM, right? And these 10x engineers and these 10x testers, and then put that together with a platform. And then what do you get, right? And then for me, like, there's like, well, what else can we do, right? And so this is actually like a little bit of a note to the Test.io folks. Expect me to come with this crazy idea of looking next at how we can leverage machine learning with the power of the crowd and those professional testers and the platform to kind of do something very innovative and automated there. So don't say I didn't warn you that I would be coming. So just letting you know. So these are all specific instances, but a general way to think about combining force multipliers is to have like a holistic picture of your digital transformation, right? Coming in and first assessing and identifying possible areas of improvement where force multipliers could be combined or applied. So for example, maybe your low performing teams, or where there's gaps in knowledge or expertise. There could be projects that have significant manual effort, right? So there's a need for automation on that side. Or maybe there's a lack of leadership, right? And so you first do your assessment, your health check, and see what are the areas that are possible candidates for improvement, and then developing a plan that you can incorporate those force multipliers over time, and doing it like strategically and being smart about it, right? Like, you want to define success criteria, but you want to think like, hey, maybe I walked into this particular challenge with my organization, and I know that there's gaps in expertise, but we don't have all this time to hire people right now. So maybe bringing in a consultant might help for that, or thinking about, the automation framework, and we want to design it and build it, but that's going to take time, right? So we start that early, but we won't see the ROI on that until later. So by having like an upfront like health check and assessment, then you can start to plan and schedule what is the kind of best plan of action or course of action to take advantage of these force multipliers. And then the last thing is to just make sure that you're adaptive, right? Like, you're not going to come up and have a plan and implement it and track it, have your KPIs without checking back and seeing how well are we doing, right? And so if you need to make changes or course correct because something is not going as expected, then you need to be able to do that, right? So it's not just a one-stop shop and move on. And one thing I always like to remind people is like the goal for these kind of transformations should be enablement. It's not about coming in and giving someone a bunch of fish, right? You want to teach them how to fish, and so by being having that in mind as a goal, you kind of go forward and make sure that, hey, even your people that are acting as force multipliers to help do the transformation are there to build people up and help them be self-sufficient and continue to grow, right? So it's about enablement, and it's also about growth in the organization and self-sufficiency at the end of the day. And like I mentioned before, like being strategic about all of this stuff is what's gonna also pay off, right? So don't try to just come in and do everything. You usually can't. So you need to be able to identify what are the low-hanging fruit, address those first. So thinking always short-term, mid-term, and then long-term. For example, culture changes might be more longer-term and take longer to happen. And so kind of thinking through that and starting from an early time while other things are going on and you're reaping those benefits is also a key. All right, so we talked about force multipliers and like what does all of this have to do with quality and testing? So here we're kind of going to jump into some philosophies of some things, right? And the first one is this idea that Q equals P, and it's really interesting. Like in my time at Ultimate Software, leading quality there, this was always like a mantra of the quality organization: Q equals P, which Q stands for quality, and P is productivity. And what does that really imply? That implies that if one side of this equation goes up or down, then the other side goes up or down, right? So these force multipliers that increase productivity generally also have the impact on quality, that quality goes up, right? And you might be saying, well, okay, well, just because we're going faster doesn't mean that we're not, making mistakes. But if you recall when we start talking about looking at these force multipliers, it's not just like, hey, one tool and we go fast. It's also about the people that are driving those things and them having a very holistic picture of what needs to be done in the organization, and obviously like building quality products and engineering products with quality has to be a part of that. It's not just go fast because we got a fancy tool. It's larger thinking than that. It's the entire process, it's the people and everything. And then ironically, like there's another kind of similar theory by William Edwards Deming, he was a famous American engineer and statistician. But he had the idea that quality is really the results of looking at work efforts with the total cost. And then when people tend to look at costs and focus on cost, then quality actually decreases. But when they focus on quality, then costs actually decrease, right? And so this is kind of like a similar thing, but now thinking about cost as a factor. And so one of the things that is important to understand is the impact on costs, right? When we start talking about force multiplication and what really happens. So let's look at like the idea of quality engineering and quality practices and the cost of that as an investment, right? So we're going to let T be an abstraction of the testing effort, right? So it's Friday. Last thing, of course, we got to do some math before we go and enjoy our weekend, right? But I promise it's not hard math. But so that linear cost of the testing effort, which is this F of T that we're talking about, is your fixed investment, right? And normally that fixed investment has some coefficient, which is that linear function. So C is the cost of maybe all the testers in your organization or people doing quality engineering functions, right? Best practices, et cetera. And then you have assets, right? So your hardware, your infrastructure, any tools that you're using. And no matter what, when you start off doing this, you're testing, like if you did no testing investment at all, you would still have a high cost for testing, because this curve that you see, D of T, is really the cost of escape defects. So if you do no testing, if you do zero investment in testing, you still have like a very large DFT. And as you start investing in quality, then you start to see it decreases. And it actually drops pretty fast at first because finding those first set of defects is usually very easy. But over time, if you have this expenditure on testing, you actually get less and less return on investment, right? So there's this like law of diminishing returns as you invest in testing too much, right? So there's a sweet spot, right? Because you have on one side your your reputation, right? And then you have this investment cost on quality. And the total cost of quality is really the summation of these two curves. So the goal would be to find like this lowest point, right? And so the key here is thinking that like the largest thing that you have to account for when you think about these force multipliers and the impacts is people, right? So for example, the force multipliers help us to do more with less, right? So whether that be process, people, tools, or technology, at the end of the day, what we're saying is that we want to be able to reduce the manual effort, because at the end of the day, people are our most valuable resource, but they're also the most costly resource that we have. And so by focusing on being more efficient and lowering that cost, or doing more and getting more features out, however we look at that efficiency, with less, we can actually be a lot more productive. But what does that have to do with the cost itself? Well, once we lower that footprint, even from a testing perspective, what that means now is that that coefficient is now less. And so this becomes our cost of our testing effort. So our T moves down and to the right. And then this is our new cost of quality by adding those curves together. And then this is the cost reduction that we saw, right? So you can see like whether it be, and this is just like kind of one case when you lower that cost, but you can see as you continue to apply force multipliers that give you more and more return, then this slope continues to go down and you get this kind of almost exponential benefit of the cost reduction for applying these force multipliers. So on one side, you have the value and the productivity and the quality improvements, which are all great in themselves, but then simultaneously, you have this reduction in the cost of quality through more automation or more efficiency in your organization. And that is usually like very golden, right? All right, so we made it through that. So we couldn't have like a force multiplier talk without having like Yoda appear, right? But just some kind of final thoughts to wrap up the discussion. The first thing is like thinking like this concept of force multiplication, both like in our everyday lives and in engineering, is actually like a very powerful concept. And we may take it for granted and we think about it every now and then, maybe, or maybe not, but really understanding that before you actually step into thinking about how to optimize or how to make something more efficient, understanding those different types of force multipliers when it comes to engineering and testing and operations is actually like, for me, a foundational step in driving that organizational change. Because if you come in and you just throw a tool at it, you're only going to get so far, right? The tool may not even get you very far because maybe the tool is lacking adoption, and maybe adoption is a result of something that's deeper within the cultural change, or maybe there's no expertise to actually drive the transformation that you need with the tools that you have or the tools that you want to impose. So it can't be kind of just this one track thing. It has to be like this holistic understanding of force multipliers. And then last but like being strategic about which force multipliers to introduce and when to apply them is also like a key part of that digital transformation strategy. And last but not least, may the force be with you, right? So as you go into this kind of season thinking about your organizations and how you can make a difference and how you can become more effective and efficient as you look at like the new year with that, like just think of these force multipliers, think of your organization and where you might have gaps or where you might be able to fill those gaps immediately versus not, which are more longer term. and then just base your objectives and key results off of those optimizations. So with that, we can open up for questions.
Awesome. Thank you so much. Okay, yeah. Everyone, please, any questions, comments, anecdotes, things that we sparked there, please feel free to throw it in chat, and we'll kind of pull out some questions from there.
Cool. I see the chairs. Thank you, Susan and Philip. I know it's Friday, you know. For some of us, it's earlier on Friday than others, but some of us, it might be later too.
Friday's always a little slow, for me at least. All right, I see a question. With the AI generated tests, are you saying anyone tying that back to revenue generation workflows and using that to prioritize dev activities?
If I'm seeing anyone doing that, so there's a couple things there. When it comes to, and this is like usually the hardest thing when it comes to AI and leveraging AI for testing, is kind of that ROI and proving out that ROI case, because some of the technology, to be frank, is still in its infancy, and so tying it back becomes challenging sometimes, right? What I can say is that like what I've seen folks doing that has been kind of effective and impactful is defining upfront their use case for a particular technology, whether it be self-healing automation, whether it be vision-based testing, whether it be test analytics using AI. Like once you start digging into what is your use case for your organization that brings value to you, and having that as part of your success criteria upfront for any kind of POC, then that is normally the effective way to go, because you've kind of baked in the ROI investment and analytics on that upfront. When it comes to the specifics of revenue generating workflows, that becomes a little bit more challenging for folks to actually, well, I haven't seen anyone actually applying, trying to tie that back in that manner. Specifically, but it definitely seems like an interesting problem to solve.
Awesome. And another one, what are some of the most often unrecognized or underutilized force multipliers?
So I would say underutilized. So, you know, we tend to use obviously tools a lot and so on and so forth. And I think in some organizations, and it really depends on your culture, in some organizations, I see that there's very talented folks at times from the people standpoint who are candidates for just accelerating and growing throughout. But if you don't have the right culture, or if you don't have the right mentorship, or if you don't have the right leaders like looking out for developing those individuals, then they can be very underutilized, right? And actually, those are folks that will probably get bored in your organization and then leave, unfortunately, which is a problem. I think some organizations also do better on process than others. So, you know, thinking about flow and how you optimize your engineering teams, how you build trust to make sure that teams are actually just open with each other and actually collaborating better. Those are some opportunities for improvement as well. So I think at the top you have tools, and at the lower ends, like people and processes kind of are underutilized, which is kind of was the point of like bringing this topic to the front, for us to not just think about technology as a force multiplier.
Awesome. Thank you. And we have another one. Which current industry trends do you find the most relevant for QA, I guess, within the context of these force multipliers? And I think we're thinking about AI, IoT, metaverse, et cetera.
Yeah, so I mean, I guess that will depend by industry, even by multiplier by industry, right? So for example, like when I think of AI, or even if I think of metaverse is a good one because everyone is kind of talking about it like it's like the new buzzword kind of thing. But when I think about metaverse, for example, I think that man, like there's a need for a lot of tooling to actually help us to be able to do what we need to do there, for automation and these different things, right? But then there's also a big gap in expertise and people who can drive some of these things, right? So we definitely have to look at that. And then for many of these things, you know, when you venture into something that's unknown or new, where there's a lot of innovation, then you normally have to revisit and revise the processes that you had in place because the processes that you had in place usually made certain assumptions on certain things, and now you have a different set of assumptions or a different set of parameters that you have to deal with, right? So definitely for something like new and unknown, all three of these dimensions of force multipliers need to be tackled. You know, things like IoT bring to mind like the need for people and the need for the crowd, right? Because like you have all these connected devices, and we really struggle to get in kind of real world feedback if you don't have a plug into the user base or the crowd itself. So that kind of jumps out when I think of IoT. And any kind of dedicated hardware and devices also requires some investment in tooling and automation as well. So hopefully that answers that question.
Oh, that was amazing. That was great. Thank you. And there's a follow-up from Ted. So if an organization was at the beginning of their force multiplier journey, which force multipliers tend to yield the greatest initial impacts, but are more of the low-hanging fruit as they go on that journey?
Yeah, that's a good question. Like, and obviously every organization is different, but what I've seen is that normally, like at the beginning of things, you tend to see that there's in an organization usually either gaps in expertise and knowledge, or a broken process, or a process that people actually don't realize is broken, right? Sometimes like you get into like their tools and stuff like that, but normally like the first thing that I've noticed is that like there's a process issue, and you have to address that. Or there might be an issue with culture that is leading to silos, and that's why the organization is crippled from that standpoint, right? So rarely do I think that it's just tools, but one of the other kind of low-hanging fruit is that maybe there's not enough investment in automating things, right? The organization is trying to scale with people, which is, of course, a lot less cost effective than scaling with technology. So that's kind of the other one that normally jumps out. But the investment in automation can sometimes take a little bit longer than, I mean, it all depends again. In some organizations, process could take a long time to change depending on, you know, if you have a lot of politics around the organization and that sort of stuff. So it really would depend, I think, once you go in. And the people who are there trying to make the change would know best where that struggle is, right? So trust your gut instincts.
And another one, do you have any suggested reading, like articles or things that have been very influential as you've kind of put together this framework?
Yeah, so I mean, I think specifically on force multipliers, a lot of the stuff that I would think that QA probably should dive into a little bit more, or quite frankly, some of the different process models and the nuances they're in, right? Normally in an organization, you may be exposed to like whatever process model you are familiar with. But I always encourage people to step out a little bit and dive into looking at different things, looking at value stream analysis, or even some of the methods that I put up there on SAFe, et cetera. That's usually like a good stepping stone to kind of get out of like, yeah, well, we aren't using this, maybe not be using this at my company, but maybe what is this all about? And is there anything there of value that we can actually bring? Or even going back to what you think you're doing and reading up on that. I think that that's a key aspect of this. When it comes down to like technologies, and normally the questions that I get around this are people trying to read up on AI and machine learning. There's a site called machinelearningmastery.com that's a pretty hands-on site that's full of actually code examples as well as articles on machine learning. So if you want to dig into that, that's there. But there's free courses online. Andrew Ng has a course from Stanford that's been out there on machine learning. Lex Friedman has a course on self-driving cars and stuff. Metaverse, like you can just search, you'll find a lot of stuff. I wrote an article on the quality concerns around the metaverse. That's also out there. And just recently got back from Germany giving a talk on kind of those challenges. So there's some information out there from me.
Have to check some of those out. Yeah, thank you very much. Well, we still have a few minutes left if there's more questions. I did have one for me. I thought that the idea that you kind of presented of Q equals P, that quality equals productivity, was extremely interesting. And then specifically, I guess trying to quantify the business impact of quality issues and sort of balance that out with the the cost of testing and the cost of finding those. So my question for you is, how do you actually assign a number or quantify some of those quality impacts? Because it is such a I feel like it varies so much depending on what business you're in and what issue you're talking about, right?
Yeah. So there's normally, like, for me, I break it down into two parts of the equation when it comes to like the cost of quality, right? There's the cost of like what they call the cost of good quality and the cost of poor quality, right? The cost of poor quality and quantifying those is usually going to be linked to your escape defects and the impacts of those, and trying to start to get some numbers around that. Like we had done a study way back when I was at Ultimate Software on the cost of each customer found defect. And back then, this is over like 10 years ago, each customer found defect with all the touch points, we quantified and estimated that it cost about $22,000. And so just being able to, even if you go through an exercise and you get a rough estimate by just looking at all the touch points, all the people in support, all the people in the development teams that get stopped, and looking at their time and the amount of time that they're spending, and just leveraging their salary information or some rough estimate of per engineer, this is how much it is, you'll be able to come up with some estimate, and that even if it's not accurate, like, it'll be useful, right? Kind of like models. So that's one thing where you have the cost of poor quality. And then a little bit easier to estimate is your investment costs, upfront costs, right? So that linear line that I put there at the end of the day, which is usually the biggest factor to that, is going to be people. So looking at how many testing heads you're employing. And then just really comparing that, right? So to any alternative, right? So when normally, like, people are trying to see how much investment they should make in a given aspect of quality, whether it be automation, whether it be some new process. And normally, like I always tell people, go back to the fundamentals, right? Like, how is it impacting your customers, like the pain that they're having? Because normally we look at those escalations and all that, but another factor to the cost that's usually hidden is the impact on reputation and the loss of sales and loss of revenue, right? Like that is a serious thing. That is, the opportunity cost is harder to estimate. But if you just look at the things that are more clearly in front of you and you start doing the cost analysis, then you should be able to see like, hey, we should invest more here, or yeah, maybe it is worth getting this platform or leveraging the crowd to do this because like, at the end of the day, we're going to save more on customer found defects and what we're currently paying. Like I always tell people, you're going to pay for quality. The question just becomes, are you going to pay for it up front and invest in it so that you end up paying less, or are you going to pay for it at the end when it's already a little bit too late and you could be running out of business at the end of the day?
Well, that's excellent. That's really, I think, distilled a lot of kind of what we understand, maybe more intuitively. But yeah, thank you so much, Tariq. Thank you, everyone, for your questions and for taking the time to join us today. I think like that's it for now. Hope everyone has a wonderful rest of your Friday and weekend.
All right. Thanks, folks. Take care.
Thank you.